Okay, problem number 6. A basketball is shot from an initial height of 2.4 meters with an initial velocity v naught of 12 meters per second, directed at an angle of 35 degrees above the horizontal. Part A, how far from the basket was the player if he made a basket? So for this one, what we can do is we can look at the vertical motion alone. So I'm going to call it delta y. And so I'm looking at the vertical motion of the ball from when it goes from here up to here. And so there's going to be this change in y, and that's going to be equal to the initial velocity in the y direction times time plus 1/2 at squared. This change in y, that's really going to be the 3.05 minus the 2.4. So 3.05 meters minus 2.4 meters. VI, that's just the vertical component of that 12 meters per second. So that's going to be 12 times the sine of 35 times the time t plus 1/2 of the acceleration is downward. If this is going to be positive, then and that's upward, and acceleration is downward, it's got to be negative then. So -10 meters per second squared times the time squared. Okay, so this is a quadratic, and we can solve this for t. And when we do, we get two values. We get 0.102 seconds. That's the first time that it reaches that height, which is over here. And we have 1.274 seconds. That's when it reaches all the way over here. And in part A, what we're trying to do is we're trying to figure out what is that horizontal distance. So that's constant velocity motion in that direction. And so I can use delta x equals v bar in the x direction times t. And this would be 12 times cosine of 35 for the horizontal component times the time we just found here, 1.274 seconds. And I can multiply that out and I get 12.5 meters. So that's the distance from here over here. Now for part B wants to know when the ball comes in here, what's the angle that it comes in? Well, first of all, that's going to be below the horizontal, but it's not going to be the same as 35 because you can see that as it goes up, I mean, we have a gradual change in that angle. So what I need to do is I need to know what that velocity is there, because I could look at it. I'm going to kind of expand the triangle here. I have a horizontal complement, Vx, and I have the vertical component of the velocity, I'll call it Vy, and I want to know what is this angle here. Well, I can use inverse tangent of the Vy over the Vx to figure that angle theta out. So that means I know what Vx is. It's the 12 cosine 35. It doesn't change. But the Vy will change. One nice thing is the velocity there at that point I could figure out. But keep in mind that's going to be the same as the velocity over here at this point too. And so I'm going to go ahead, I shouldn't say velocity, it would be the same as the speed at that point. So I'm going to go ahead and find the speed at that point and then substitute it in. So the y component of the velocity is going to be equal to 12 sine of 35. But that's there. If I want to figure out this, it's decreasing because of the acceleration. So it's going to be minus 10 meters per second squared times the time. And I'm going to go ahead and use this first time of 0.102. So 0.102 seconds. I could have used the other one. Doesn't really matter. Anyway, when I figure out the speed here, I get 5.863 meters per second. Now I can do the inverse tangent. Inverse tangent of the 5.863 divided by the 12 cosine 35 and that's below the horizontal. I suppose you could also say negative 30.8.